Hey guys, welcome back to the channel. So a couple of days ago, I have noticed this question, how to integrate AI project with the embedded system for your real-time robotics project. And I think it's such a good question that I didn't answer. And that's why I'm making this video, because I'm pretty sure there might be you too wondering about how to integrate AI project with embedded system for your real-time robot. And then my answer is that it's actually easier than you think. It's quite straightforward probably. And I'm saying this because even a decade ago, I have built this gesture recognition drone that can automatically take off and landing based on your gesture, and that is done by this deep learning algorithm. So let's talk about how you can set up AI project with your embedded system with the simplest and minimal setup for your project. And if you're new to here, my name is Elliot. I'm a robotics engineer, educator, and entrepreneur providing related services. So first things first, how to integrate AI application with your robot, especially like embedded system like Arduino. Literally, the answer is this. Use this, one of the USB wire like this, which is just trivial, and then connect them, and then send the information from your laptop or PC, and then send the data like velocity or position or any other information that you need in your project, and then send that to Arduino like embedded system. And if you're not using laptop, of course, you might be using Jetson or Raspberry Pi like embedded computer, which is just like average computer. It's just based on ARM CPU architecture, and then it just function like any other laptops. And then the reason why people use this kind of computer is because it's more like optimal for power consumption. And then you send the data. Then you might be asking why you need a separate microcontroller or a separate computer like this, why you cannot just implement AI algorithm into this embedded system. And then the quick answer is that embedded system like this is really small and has limited resources. So it is better that you still use this kind of regular computers. Then the follow-up question might be what kind of information, how to decide which type of application gotta reside in your laptop like PC, and then what kind of information or controller algorithm needs to be implemented in this microcontroller. Perfect question. So before I answer that, let me talk about the embedded system and the purpose of the embedded system specifically. And then if you are not familiar with the embedded system, actually embedded system, like this guy, is actually everywhere in your home appliances, and it controls like on and off your temperature, your LED light bulbs, and so on. And then it does the same thing for the robots to control your motor RPM, how fast it is, or turn left and right. It's all based on this kind of embedded system. And then the most beginner-friendly embedded system is called Arduino chip like this, and then you can find tons of examples on the internet. And then you can also order this from Amazon. So when it comes to robotics engineering, this kind of embedded system is specifically designed for controlling the motor RPM. Like if it is a robot dog, it needs to control the joint angle of the legs and the arms. And if it is drone, you need to control this propeller RPM to go up and down, literally. And then the rule of the game for robotics is that the embedded system needs to control this kind of feedback loop like 400 times per second. And that is 400 hertz. That needs to be done really quick. However, when it comes to modern day computer like this or Android application, it comes with this feature called scheduler. And scheduler is literally letting user like you, like literally we can download the file while we're listening to music or watching YouTube videos, and then we can also work on the web browser, typing something, create something, and so on and so on. So that is all possible because of the scheduler on modern day operating system like Windows, Mac, Ubuntu. However, the downside of the scheduler is that you don't have control over the scheduler, while your task for robot is to control the motors at 400 times per second, but scheduler doesn't respect that. So this type of microcontroller doesn't come with operating system, so it doesn't have any scheduler. So you do have full control over this frequencies and update rate for your robot. And that's why you want to use embedded system. Although I have been talking about a little bit of operating systems and scheduler, it may sound scary. I mean, it scared me a lot when I first heard about it. However, like I said, just Google Arduino example code, and then there are tons of examples, and it's really, really straightforward to get started with this kind of embedded system. Now, here's the most important concept. So whenever you work on or start new robotics project, always think in terms of control block diagram, because robotics is about controlling the hardware from your software. So to be able to do that, you need to complete the feedback loop. And then this control block diagram is the minimal mental framework for doing that, accomplishing the feedback loop. So typically, the robotics project comes with a controller like this, and then system, and then observer or sensor fusion or state estimator. They also called state estimator like this. So what's the deal about it is the control is about calculating the error. So if your robot needs to go to a certain position and then it measures current position, like implement a current position, and then your target position is in XYZ in the 3D coordinate, and then that is your error. And then controller will calculate what kind of motor output needs to be done to compensate this error. And then a control output will be fed into this system or plant or actuator or whatever that is. And then simply this is about this physical property of your robot. And then this system is, and what the system is about literally and high level is the system property of your robot. For example, if you never built any Mars rover on Mars because you've never been on Mars, but you know the gravitational acceleration of the planet Mars, then you can actually put that specific number for the gravitational acceleration of the Mars, and that is about the system design and system identification. And in more detail, like velocity control like this can be in a loop of the position control, because the velocity control really needs to be done really quick, like 400 times or 1000 times per second. That's like 1 millisecond. So every millisecond, you need to calculate all this to compensate the velocity of your professional robot project or whatever that is. And that's why we're using the microcontroller like this. Now, when it comes to position control, the update rate can be a little lower, like, I don't know, 60 hertz per second or 30 hertz per second or 10 hertz per second. So this kind of task position control can be calculated on the laptop like PC or Jetson Nano series like PC. I mean, it all depends on your project requirement, but I'm just giving you as an example. So that's how you want to design your robotics project. Now the question is, okay, then can AI measure the position? Can AI measure the velocity of your robot? Because it has a camera, and then using the computer vision algorithm, you can maybe estimate the velocity or maybe detect object and then generate a new path for your car to avoid these obstacles. At that point, what you are doing here is that you are not accomplishing the position control loop using the AI. Instead, as you can see, here's the set point here. And what AI is doing for the object detection and then avoidance is generating a set of XYZ positions for your car to move around to dodge any object. And you are generating XYZ positions like this as a set of positions, right? And then all these XYZ, say array of the position or array of 3D vector, is fed in as a set point through the USB cable from your PC to microcontroller. So that's how you design the AI project with your robot. So here's another actual example that I did previously. So after you detecting the human gestures like this, idle gesture, landing gesture is going to be like this, like I raise my hands, and then proceed gesture is like come towards me, and then the other one is go back. That's just my definition of these gestures. And then using this RNN and CNN, it can literally classify which gesture it is in real time. And then what I did next is to define this state transition machine. So when this drone is on ground, when I do this gesture, and then the AI will detect, okay, that's the detected takeoff gesture. Then the state machine will transit to pre-flight, and then this pre-flight module will send the set point for the position to take off, which, for example, what kind of height above the ground. So that's the set point coming out through the micro, and then saying, if the state machine on your, say, this is my laptop, and your computer vision algorithm detects a new gesture and that it transit to tracking position of your drone like another object, then it sends out the array of the positions to this microcontroller. So that's your laptop and that's your microcontroller working together. How? Literally using this USB. And with a little bit more detail, like you might be wondering that how to actually send the data through the USB. Well, if you're using Python and Arduino, you can just use PySerial, and then sending data and reading the data from the microcontroller is really straightforward. Just try with this beginner-friendly Arduino board, and then you will know what I mean. And then literally you can just send a stream data to Arduino and then back and forth. But if you want to optimize a little bit more, if you want to use flat buffers, just go to GitHub of Google/buffers like this, and then go to release page, then download one of these release like Windows flat buffers and so on, and download it, unzip it. And then this flat buffer comes with all these various languages like TypeScript, Rust, Python, C++, Kotlin, Java, and so on, you name it. So it's much abundant. So in whatever application you develop for your AI, you can actually send the binary data to your microcontroller, and the microcontroller is based on C and C++. You can unpack that binary data into meaningful data. What do I mean by that? So after you download and unzip the C++, the flat buffers, like it's going to be like this. And then you define your vector array like this, X, Y, Z, which is float, and vec3 message like this. After defining this vector3.f, then you just run this flat c.exe and then name of this file and then make it as a Python. And then it will generate this vec3 msg.py implement automatically generated by this exe file. And then what you need to do is define flat buffers like this, and then encode vector3 like this, and so on. So if you define any vectors, say these numbers are coming from your AI application or any other application in Python or other languages, and then you can encode all these data into binary data. You don't have to, but if you send the binary data, it's more optimal for your data communication because it's more compact data. And then your binary data is here, and I'm printing the binary data, and then you can also decode this binary data. So if I actually run this program, it's just going to encode the binary data like this as a byte array. And this is actually the byte array that you can send using the Pi serial that I just showed you. Then you can also decode all these binary data in your microcontroller as an actual value like X, Y, Z. And then you can do any other operation for precision control, velocity control, and so on and so on. Or if you don't want to do any things like flat buffers and so on, just use ROS. It comes with a little bit more entrance barrier, but you can also use ROS as well. However, the downside of the ROS is that it's a data-centric, not your app-centric. So your app has to follow the rule or ecosystem of the ROS build system. Like some people, including myself, honestly, what kind of tool comes with a rule that I have to follow instead of tool serve my app, right? If that's the case, you can also try RabitMQ. This is more like an app-centric data protocol for subscribing. And however, the downside of this Rabbit is that it has a singular point because it has a broker in the middle of the data communication. So if the broker is down, then your app is down. However, what's the odd of this broker down? The web developers, the backend developers are not idiots. They are smart people, and they are using RabitMQ to control this data flow all over the world. Only difference is that ROS is based on the DDS, data distribution service, and it's more optimal for like real-time and fast data protocol. And what I do in practice is that I just kind of mix them together using ROS and RabitMQ together. So these two tools are good application or good convenient tools on your side as well. So those are the two sort of software-wise things that you need to consider to get started with. And then, like I said, the core essential idea of the robotics is about the control engineering. You got to control the stuff. Otherwise, it's not really a robotics in my head. It can be. And it really, again, based on your definition of a project, I'm not like saying what's right or what's wrong. I'm not interested in that. Instead, if you're more interested in like the autonomous vehicle and controlling something like robot arm, I don't know, joint angle of your robot dog, and so on, you need to consider this control block diagram. And then this control engineering comes with the three portions. One is literally control theory, then sensor fusion, and then decision making. And then control theory is literally about something like PID control. Then, because it's a system or plant, what you need to do is consider dynamics, kinematics. If it is like a typical robot arm, those are important. And then if you are going for fixed wing robot like drone, then you need to, study the aerodynamics, mechanics, whatever, that comes with the dynamics. Like even thermodynamics, if you're like controlling some kind of chemical solutions with your robot, then you might need to consider, thermodynamics and other dynamics in chemistry. So that's all about your system. And then sensor fusion is actually often called in perception as well, because sensor fusion kind of expands to the computer vision like object detection. And then all these ideas are emerging from this control engineering centric sort of philosophy, I'd say. So you can always get into the robotics field from, software engineering, computer vision, LLMs, and so on. You name it. Always just set your sort of position at the center of the control block diagram. Then you can plan what needs to be done for your robotics project. So we talked about how to connecting AI project to your embedded system together and then let them work together. But what's more important is the first principle of the robotics, because the control block diagram is all about controlling or managing the information flow in your real-time robotics project. So before considering anything throughout your robotics career, it is very important to understand the first principles of robotics, like PID control, what is the feedback loop, what is the control block diagram. And this understanding, the mind map within your brain, will be self-guiding for you. Without this control engineering in your mind, the robotics field can be very random for anyone. So I wish you don't get lost in this field. If you wish to establish a solid foundation in robotics, please check out the comment section down below, because I have explained how to get started with robotics in more detail. And then hopefully I'll see you in the next one. Bye for now.